You know, for decades, we've been told one thing about our minds. The brain is a computer. It runs software, it processes data, it stores files. It's a powerful metaphor, for sure. But what if it's holding us back? What if your brain isn't a machine made of circuits and code at all? What if it's something more fluid, more dynamic, more alive? Let's explore a whole new way of thinking about thought itself. So, what we're really talking about here are two totally different ways of looking at the mind. On one side, you've got the computer. It crunches symbols, it follows strict rules, and it's kind of separate from everything else. But on the other side, we have this idea of a dynamic system. Here, thought isn't a calculation, it's a continuous, flowing process, totally intertwined with our bodies and the world around us. All right, so before we dive into the new stuff, we've got to talk about that old metaphor. Let's really break down why it might be time to move on.
So, what's wrong with the whole brain as a computer idea? Well, it kind of falls apart when you look closer. It forces us to imagine thinking happens in these neat little clock ticks, like a CPU. It assumes our brains are just shuffling abstract ones and zeros, but that view completely separates the mind from the body and the body from the world. And it sees time as just a metronome ticking away in the background, not as something that's woven into the very fabric of thought itself. Biologically, it just doesn't quite add up.
So, if the computer metaphor is out, what's in? Well, that brings us to a much cooler, more powerful idea, the dynamical hypothesis. Okay, this is the big idea, the real game changer. The dynamical hypothesis says that thinking isn't about running a program. It says that thinking is the continuous physical evolution of your brain state through time. In a very real way, a thought is a form of motion. To really get a feel for this, I want you to imagine something. Picture all the activity in your brain at this very second. Every neuron firing, every chemical changing, all of it represented as a single ball. And this ball is rolling across a vast, complicated landscape of hills and valleys. Now this landscape, it has a technical name. Scientists call it a state space. It's basically an abstract map where every single possible state your brain could be in is one specific location. And here's the key. The path that the ball takes across this landscape, that is the thought. Thinking isn't something that happens on the landscape. The journey itself is the thought. Okay, so if thinking is a journey across this landscape, what does the map look like? What are its features? Let's take a look at the architecture of our thoughts. The most important features you'd see on this map are the valleys. In the language of this science, they're called attractors. These are stable, coherent states where the activity in your brain naturally wants to settle. So an attractor isn't like a thought or a memory. An attractor is a thought or a memory. And this is where things get really cool, because it gives us this beautiful, simple way to understand memory. Let's say a specific memory, like your childhood home, is stored as a deep valley in this landscape. Now, imagine you get just a tiny clue, maybe a faint smell of cookies baking. That clue is enough to place the ball of your brain state somewhere on the slope of that valley. And then, physics just takes over. The ball naturally rolls downhill and settles at the very bottom, and in doing so, you retrieve the full, complete memory. It's called pattern completion, and it's amazing. And what's wild is that the actual shape of these valleys, their geometry, tells you what kind of thought it is. A deep, single point, a point attractor, that's a specific memory or a firm decision. A circle or a ring attractor, that could represent your brain tracking which way your head is pointing. A closed loop, a cyclic attractor, that's the basis for rhythmic stuff, like walking or breathing. And these complex, beautiful fractal shapes called chaotic attractors, they might just be where our most creative and generative thoughts come from. The shape of the landscape is the shape of your mind. Okay, wait a minute. If our thoughts are all these nice, stable valleys, that brings up a problem, right? How do we ever get out of one valley to think something new? How does our stream of consciousness actually flow? This is a classic problem in neuroscience. It's called the stability-flexibility dilemma. See, if the valleys are too deep, your thoughts are super reliable, but your mind is rigid. You get stuck in a rut. On the other hand, if the landscape is totally flat, you're flexible, but you can never form a single stable thought. Your brain has to find that perfect sweet spot. And the brain's solution is just elegant. It's a concept called metastability. The idea is that the valleys aren't super deep canyons. They're more like shallow dips in the ground. Our brain state can settle in one for just a moment. That's a thought, but it's only temporarily stable. With just a tiny nudge, it can easily roll out and into the next valley and then the next. It is the perfect sweet spot between rigid order and total chaos. It's funny, the philosopher William James was way ahead of his time on this. Over 100 years ago, he described our stream of consciousness as being made of perchings and flights. Those perchings, that's our brain state, resting for a moment in a metastable valley. And the flights? That's the fluid, effortless transition to the next thought. So, what's the engine? What's the force that keeps our brain in this perfectly balanced, metastable state that allows for this beautiful flow of thoughts? The answer actually comes from physics, and it's a mind-bending idea called criticality. Imagine a system that is perfectly tuned, right on the tipping point, the phase transition, between being too orderly, where activity just fizzles out, and being too chaotic, where activity explodes everywhere. The brain seems to be constantly tuning itself to operate right there, on the edge of chaos. And why would the brain want to live on this knife's edge? Well, the advantages are huge. Operating at criticality maximizes the brain's information processing power. It gives it the biggest dynamic range, so it can react to both faint whispers and loud shouts from the environment. And it allows for the most flexible, creative, and robust thinking possible. We can even see the fingerprint of this state in the brain, in these things called neural avalanches, cascades of activity that spread in a very particular way. Okay, so let's pull all these threads together now. Let's build the complete picture of this living landscape inside our minds. It really boils down to this. Thinking is the act of navigating the landscape as it is right now. Learning, that's the act of physically reshaping that landscape for the future, carving new valleys and building new hills by changing the connections between your neurons. And this leads to one last, really beautiful idea. When your brain is just at rest, it's hovering just below that critical point. All your memories, all your potential ideas, they exist as a latent landscape of what you could call ghost attractors. And the brain's own natural background noise, which is energized by being so close to that edge of chaos, is constantly exploring these potential thoughts, lighting them up for a moment before moving on. So, there you have it, the whole picture. The landscape is the structure of your mind, built over a lifetime of learning. Criticality is the engine, the energy that lets you explore that landscape. Metastability is the result, that fluid dynamic of moving from one thought to the next. And thinking itself, it's the beautiful, self-organized journey that emerges from the whole shebang. So when you see it this way, the mind isn't some cold, calculating machine. It's a living, breathing, dynamic landscape that you have the power to change. And that leaves us with one final thought. If thinking is navigating this landscape, and learning is the power to reshape it, what new paths will you create?